was Sputnik.
Yeah.
I was 16 years old, and the same size of a volleyball or basketball, going beep, 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 and gee, that's neat, because my marks in high school were equally good at humanities and sciences and math and so forth. And between high school and university, I got a job with the Ontario Department of Mines, as it was then, Geological Survey now, with J.E. Thompson, who eventually became its director. And I knew nothing about geology, but I spent the summer with him in the Sudbury area. And I met Dietz, the meteorite impact guy, and we went on a field trip. Again, I had no concept of what they were talking about. And I decided to take I was going to be a chemist at university, and I decided to take a first-year course from Archie Reed, who taught a really good course in first-year geology, and it introduced me to something called geochemistry. Geochemistry, I could combine the love of the outdoors with chemistry, so my PhD is in geochemistry and mineralogy. I spent a summer working for U.S. Steel, and Jules Anderson was party chief. And we went into the Nemegos Alkman complex, and there saw magnetite apatite bodies, and beautiful crystals of magnetite and apatite. And I decided I'd like to know how it formed. And it looked to me like it was a melt. Remind me, this is a third-year student looking at it. And so I decided I was going to try and melt fluorapatite, as it was, and magnetite. Cranked up that muffle furnace as high as it would go, and something like 900 degrees. And I got some reaction, but no melt. But I sent my results off to O.F. Tuttle, who was a very well-known petrologist at the time. He'd done some work on things like this, and asked his advice. And he wrote back right away. This is before email, this is letters, and gave me some advice. But I realized that, gosh, that there's something to this experimental work. It is a lot of fun. And so that was my bachelor's thesis. As part of it, Gary Boone, who is a petrologist at Western, University of Western Ontario, took me down to see his friend Phil Orville at Yale, I think it was Yale, and introduced me to Phil and doing hydrothermal experiments in gold tubes. And so I ran a few things in gold tubes in Phil Orville's lab. So again, more experience. I thought I'd be a mine geologist, so I better go learn something about mines. Gordon Suffel was the ore deposits professor at Western. Showed me some samples from cobalt, and that really interested me. And so I went up and spent 3 months or so mapping underground at a mine in Galganda, the Cisco Metals mine, and did my thesis on that. Subsequently discovered my grandfather had been a prospector up in the cobalt region and at Elk Lake. He didn't find anything, but he wasn't a very good prospector. But there's something in my blood, I guess. Mapped underground, sampled. I was the only one at Western who knew how to run an X-ray diffraction machine. Not even the professors knew then. So I had this X-ray diffraction machine all to myself, and so I identified all these funny arsenide minerals. They're all white or gray, and except safflorite, which is blue in reflected light. And so I worked out the mineralogy from basic principles and wrote my thesis. But I still had this desire to go back into experimental work, and I said, research is fun. Gee, maybe I should think about a PhD. I was particularly interested in Penn State because of one guy, Hubert L. Barnes, H.L. Barnes, and he was sort of at the top of his game. He was very young. I was only a fourth graduate student, and again, it was a major turning point in my life because that guy was a huge influence. And another advantage, there were people like Wayne Burnham and others there too, and Peter Wiley, all these very famous petrology, geochemistry people. And so I got a fantastic education. Did my PhD on the stoichiometry of zinc sulfide, the sphalerite worksite transition, which was said to be a very high temperature transition around 1200 degrees, and I convinced enough people, I think at least, that in fact it was sulfur activity and temperature with control. You could get the transition to occur at much lower temperatures if the sulfur activity was low enough. Gave my very first talk at AGU. A very prominent geologist from USGS stood up in the front row and said, "There are so many things I disagree with in this paper, I don't know where to start to ask questions." That was Paul Barton. And we became good friends. And I never did convince him I was right.